quick recap. We start with having a look at the water quality, basically conductivity, and which technologies we need to achieve which water quality. And then we'll go to the new permeate staged units and have a look at the features. So conductivity, as I explained just now, electrical conductivity measures the ions we have dissolved in water, basically. Since it's easy to measure, it's a parameter that is used very often for measurement of water quality. We also have resistivity, which is the reciprocal value of the conductivity, which is used more in ultra-pure water applications. For example, if you have 10 microsiemens per centimeter, that's 0.1 mega ohm. If you go to very low values in conductivity with the microsiemens, it's hard to distinguish anymore, and then it's easier if you use mega ohm, so resistivity. If you look at our water type, the raw water that we use, usually we have, let's say, drinking water with a typical conductivity of less than 1000 microsiemens per centimeter. Our units are usually capable to treat water to the specifications up to 1000. Usually your drinking water has less conductivity. It's probably around 500, 600. Brackish water, you remember brackish water units webinar, that goes more up to 5000 microsiemens per centimeter, approximately. And seawater is around 35 to 45,000 microsiemens per centimeter. Now, if we see where we end up after treatment, we have a look at the values, electrical conductivity after water treatment. Normal, typical standard unit would be a single stage RO, UOD series, for example. Typically, you get a conductivity of less than 20 microsiemens per centimeter after treatment in the permeate. Of course, it depends a bit on your water quality in the inflow, but if you have up to 1000 microsiemens per centimeter in the inflow, you would have less than 20 in the permeate. If that is not sufficient, because you have stricter requirements, the easiest option is, for example, to use high rejection membranes. Then you go down a little bit more. Or if you have, if you need less than 5 microsiemens per centimeter, to use a double stage RO. We call that a permeate staged RO, and this is the unit we're going to talk about in this session. If you need still lower conductivity values, let's say under 0.2 microsiemens per centimeter or under 0.1, you would have to use an electrodeionization as a second stage after your RO. So you could have the combination of RO and EDI, or RO, MEG, that's the membrane degasser, and EDI to reach even lower values. We'll have a look at where you actually need these low values. So if we look at different industries, in many industries, you need very normal, like 20 microsiemens per centimeter typical values. Surface technology used to be also more or less 20 microsiemens per centimeter for a lot of the, let's say, rinsing water. Nowadays, lots of clients specify that they need less than 10 microsiemens per centimeter. And this is already in between the stages. So very often you might have a single stage RO installed. And maybe now, if you need less than 10 microsiemens per centimeter, you need to think about a double stage or permeate stage RO. In the pharmaceutical sector or production of green hydrogen, we usually need a conductivity of around 1 microsiemens per centimeter, approximately, sometimes even down to 0.1. And if you look at power plant applications, there it depends a bit on the type of boiler, the type of power plant, the pressure rating, but usually you need a pretty low conductivity of less than 0.1 microsiemens per centimeter. So here we are already in the range of RO plus EDI. And finally, if you go to microelectronics, for example, you go down to the really theoretical limit under 0.1 microsiemens per centimeter. And here you can see already why it's easier to use resistivity. The difference between 0.1 and 0.05 something doesn't look like much. It is actually a big difference. And in mega ohm, you would go from 10 mega ohm to 18. So there you actually really see that you are changing the quality specifications. If we want a unit for microelectronics, we also have to think about what happens after the RO and EDI. So for example, what happens in the tank? Do we get some solution of CO2, which will drive up the conductivity again? So that it gets a bit more complicated. But now we want to focus more on let's say, the left-hand side of this slide, surface technology, less than 10, less than 5, maybe 2 microsiemens per centimeter. Now I want to show you something else that I mentioned just before with the tank. We also have some influence of CO2 on the conductivity, and that's why we need a membrane degasser to get to really low conductivity values. You can see here the carbon dioxide forms you have in the water. So you have CO2, you have bicarbonate, HCO3 minus, and you have carbonate, which is CO3 2 minus. These forms can transfer one into the other, so they are in an equilibrium, and it depends on the pH value which form is the most common one in your water. Bicarbonate and carbonate cannot pass the RO membrane because they are charged and they are held back, but CO2 is a gas and therefore can pass the membrane. Now, when CO2 passes the membrane, it's going to dissolve again later in the different forms, and you will see, because of the charges of these ions, an increased conductivity and a reduced pH in the permeate. So that's why we sometimes need to remove CO2 as well, and we need to include a membrane degasser. Or, easier option that probably you have used in other projects as well, we can dose NaOH to drive up the pH value, convert CO2 in bicarbonate, and remove it that way. Okay, this is the quick recap of conductivities, of what technologies you need to reach a certain conductivity or a certain water quality. Now we'll jump right into the units actually. So we'll go to part 2, and that's the new RO series. You can see already it looks a bit different than the old one. And you can see that we have two types of sizes and two types of units, sort of, right? So on the left hand, you see the unit sizes 200 and 400, 200 and 400 liters per hour. And on the right hand side, you see the 750, 1250, and 1700. We changed the unit sizes. If you remember from our catalog, it's different than it used to be. I'll explain in a bit why. And you can see that the smaller units, immediately they have this cover, so you see a difference. We also have differences with the pump and a few other features. So first of all, why did we do this? You can see here the old unit, and you can see already from the rotameters for measuring the flow that this is quite a different system. So the old unit was the last one we had in our portfolio with the RO5000 controller. It's a good controller, but the thing is, with this controller, you cannot really check all the values. So you cannot check flow rates, you cannot check pressures, you don't have any warnings. You see them visually, you can adjust them, but you don't have really any checks in the controller and any safety measures, let's say. We also, so we wanted to replace the controller. We also wanted to transition to more energy saving operation. If you have heard the last webinar about the brackish water units, you know that we want to use a lot more variable frequency drive pumps because it makes sense from an ecological point of view, but also from an economical point of view. And finally, we wanted to have more flexibility for retrofitting and also for the installation. The advantages of the new series are we can monitor all the values with the RO digital controller. We have an energy saving version from size 750 on with the variable frequency drive pumps. And we can retrofit now, or you can retrofit old units, old UOD units to a double stage now. That was not possible before. If you install the Permeate stage series directly, you have a more flexible installation because you have two separate stages, so you can also position them one apart from the other. And for the smaller units, you have a smaller footprint. If we look at Permeate staged units in general, you see they are designed as all the other units for a TDS of 1000 milligram per liter in the feed and a temperature of 15 degrees Celsius. We have a typical recovery a bit above 70%. That's because of the two-stage system. If you look at the two stages here, you see the first pump, stage 1, second pump, stage 2. And we have usually a recovery of 75%, typical one in the first stage, and 85% in the second stage. We have a typical conductivity in the permeate of the second stage of 5 microsiemens per centimeter. And you can see here also in the flow scheme that the concentrate of the second stage goes back into the feed. That is because the concentrate of the second stage is pretty clean, because we actually feed the second stage with permeate already. So the quality is definitely better than feed water, and it's going to improve our feed coming into the first stage. We use these units mostly in surface technology, chemical industry, cosmetics, sometimes in hospital applications, usually applications where you need around 5 microsiemens, somewhere between 10 and 1 microsiemens per centimeter. And finally, what might be interesting for you, we had a look at the units we have sold in 2020 and 2021. And all the sizes under 2000 liters per hour were over 90% standard. Practically all of them were standard. And the sizes that are larger are usually custom made, which means they are equipped with a PLC. They might have different measurements. They are project units for a certain application. This has led us to consider that in the modifications. And what we have done is we have switched from RO5000 to RO Digital. You can see here that we have 2 stages now, each one with its own controller, RO Digital. This has the advantage that you can measure all the values in the first stage and in the second stage. Okay, and we operate the 2 stages, the first one as the leader that gives the signals that is connected to any outside inputs, and the second one as the follower. We have decided to offer unit sizes larger than 1,700 liters per hour with a PLC, because as I've shown you, all the large units are usually customized anyway. And for this reason, we have also included just the smaller units in our catalog. So you'll find units until 1,700 liters per hour in the catalog, and the larger ones can be inquired directly with the sales team. That is because the larger ones are always adapted. So remember, when you see the catalog, the series doesn't stop at 1,700. We just haven't specified the larger sizes because they're anyway usually customized units. And if you need a customized one, you can just inquire. If you look at the pumps, you saw already in the slide before that we have 2 systems. The smaller units with a cover, these are equipped with the vane pumps, the small pumps. And the larger units, such as the one you see here, they are equipped with a variable frequency drive pump. The pump of the second stage is for both versions, vane pump and centrifugal pump, in stainless steel. We need that because we have already a relatively low conductivity, so the water is more aggressive, so to say. Some of the fittings are also done in stainless steel, but if you look very closely at the units, you see that some fittings are also done in brass. It was before like that. We have not changed it because it's only required to really use stainless steel for certain parts of the unit, and where we don't have problems with brass, we still use that. Okay, you see that the permeate stages are designed as separate entities. It's very obvious here. First stage is a standard unit. On this slide, that's the stage on the right-hand side. You can see that immediately because the second stage doesn't have a pre-filter. So you see this blue filter in front. The left-hand side doesn't have a blue filter, and it doesn't have this solenoid inlet valve because it's directly connected to the first stage. But it comes with a set of 2 hoses. You see those as a connection between the 2 stages, plus a cable for the connection to the first stage. Just a quick look and a recap of the controllers. What we had with the previous controller, the RO5000, we have used that before for all the 2-stage units, so for the KR and the NDP series. Last year, we already changed the KR series to PLC. So now it's equipped with the S7. We have changed the NDP series, that is now called P series. We're talking about to RO Digital, because they're usually smaller units. So it doesn't make sense to go for a PLC controller for a relatively small and, let's say in comparison to KR, not so expensive unit. Would be too large a part of the total cost. All right, But for the customized units, remember, it makes a lot of sense to go for PLC because you have more flexibility. Okay, you see that here we had already some data logging, but we couldn't monitor and obviously also not log any flows and pressures. So whatever we had as logging or warning signals was very, very limited. And there was no connection to any central control system. We can connect to the central control system now. With the Arrow Digital, you all know the controller. You can monitor all the flow and pressure values. You can also log the data. And if you choose some sort of interface, you can connect to the central control system. We have a few interfaces available. So I show you here the main ones. Remember, you can also find that in the catalog. We have Profinet or Profibus interfaces, Modbus RTU or TCP, and finally also BACnet. Usually when you include an interface, that covers the hardware and the engineering costs, and we can transmit 30 data points. If you need more data points, that's an extra charge, but 30 is really plenty. The good thing is you can also choose from a pretty wide list which data points you want to implement. So whether you want certain values that are measured, whether you want alarm signals, so you can actually specify in the central control system which alarm has occurred, up to a lot of other stuff. What is important to remember is we have two Arrow Digital controllers, so we would also have to connect to two interfaces. In most cases, it won't make sense for you to actually have two interfaces. So we recommend to take the second stage because that's actually the critical one where you want to really have the water quality, and to connect that with an interface to the central control system if you want to have the data. For the larger sizes, as mentioned, we can offer the PLC, and there you are completely flexible. Remember also, for the larger stages, we won't have this separation into two entities. For the larger stage, it's completely customized, so it's probably going to be one large unit with one PLC. Okay, big change also with the last webinar are the variable frequency drive pumps. We had a webinar about energy efficiency. I think actually, let me ask my colleagues, that was 2020, right? So you can find that as well. For those of you who haven't attended the webinar, we talked a lot about all the details about energy efficiency. Why is a variable frequency drive worth the investment? What are the advantages apart from energy saving? And if you want to brush up your knowledge on that, have a look at our YouTube channel. You will find the webinar there. The advantages with a variable frequency drive are basically that you don't have to throttle the unit to reach your operation point, so you don't destroy energy. You just adjust your energy consumption exactly to the point that you need, so to reach exactly the operation point that you need. Apart from the reduced energy consumption, you have also less noise emissions. So when you walk past the plant with a VFD pump and a normal pump, you will really hear the difference. You have a soft startup, so you don't have so much fluctuating pressure, so you protect your unit as well. It's better for the unit. It will extend the lifetime, and you can use the same pump for a 50 or 60 hertz supply. So no matter if we send the pump to whichever country with a different electrical network, we can use the same pump. We don't have increased delivery times and so on. Here are just a few examples. I showed that also in the last webinar with the brackish water units. Energy consumption can be reduced quite impressively with a variable frequency drive. So if you have a higher temperature or you have a lower TDS than what is expected or what is the operation, the design point, you can already really save a lot of energy. If you have more feet water pressure than what we specify as the minimum, you also save energy. I see there's some percentage values missing here. Basically, what you need to remember is it is something that happens very, very often, that you don't run the pump exactly at the design point. And it's really worth it to use a variable frequency drive because your end client will save a lot of money with that. So usually we have a payback period of maybe 6 months, 1 year. And after that, you actually really save a lot of money with this unit with a variable frequency drive. Okay, we'll go to the next change. So now I want to show you really sort of with an overview how these units are connected, because this looks in the beginning a bit complicated. You see here the first stage, and you will see in the lower left-hand corner that is designated ST1, that means stage 1. So this is a 200 unit. You see we come in, we have the pre-filter, we go to the high pressure pump, and we have the membrane, concentrate goes out at the bottom, is discharged, permeate goes on, and goes to the second stage. You see here we have the connection AA. There you connect with the hose. Then we come into the second stage. You have the pressure sensor, you have the high pressure pump, and your membrane. And then you go down with a concentrate. Now you come out with a concentrate, you have number 1, a concentrate recirculation. That is sometimes necessary to achieve a sufficient overflow rate to prevent scaling. Then you have actually a concentrate outlet, that's this one. And the concentrate, remember, goes back to the first stage. So the concentrate is connected via hose, that's the BB connection, and goes back. The concentrate is not the only thing that goes back. If the permeate quality after the second stage is not good enough, we have the permeate recirculation option. So at the startup, we recirculate the permeate. So we go up and then we go to the left. And then this permeate recirculation goes together with a concentrate recirculation to the first stage. And finally, we have also a permeate recirculation that actually comes from the first stage, but is here implemented in the second stage. That's the short connection just after the A. So you just take together, that's this one exactly. So you take one permeate recirculation from stage 1, the second permeate recirculation from stage 2, plus the concentrate recirculation. All that flows together and goes back with a hose connection to the first stage. It looks a bit confusing if you look at the diagram for the first time. My colleagues are nodding here behind the camera. But the advantage is you have only one connection. So you need just one hose to connect the permeate, and you need one hose to connect everything that comes back. Okay, it's important to remember. Now we go to the same thing, but for a larger size. This is the 750 unit. So you see also stage 1, stage 2. And you see the same thing. You have a connection AA and a connection BB coming back. And if you look closely, you also see you have one permeate recirculation, another permeate recirculation, right? That's stage 1. You have the permeate recirculation from stage 2, which I do not see immediately here. Yes, I guess that's that one. And you have a concentrate recirculation, if necessary, at the bottom of this block. So remember, all the flows that come back from the second stage, be it concentrate recirculation, be it permeate recirculation, they all go back to the first stage in just one hose. Okay, when you look at the stages, each of the stages has its own designation. You see here that is designated with the name of the unit and the common article number plus stage 1 or stage 2. So you see here UOD 400P, top one is stage 1 and bottom one is stage 2. You see that each one has a kilowatt connection value. This is because each one is connected separately to the electrical supply. Now, how do these work together? The first stage is the leader. So when we switch on the first stage and the pump is on, plus the permeate valve is open, stage 2 gets the request remember it's connected via a cable, to start up as well. In order to make this easier, we have changed the settings slightly. So the first stage comes with slightly different settings. The pump startup delay is only 10 seconds instead of 1 minute, so you don't need to wait for so long. The second stage can start up quicker. And in the second stage, you also have a delay, so it's stopped due to low pressure fault only after 20 minutes. So you can get 4 low pressure fault messages, and only at the 5th, after 20 minutes, it's stopped. That gives you time to properly set up the first stage and the second stage, and to have it running smoothly before it drops out because of a fault. So the second stage can send a fault message to the first stage. Obviously, that's necessary. If it has a fault, the first stage should stop as well, right? We use the digital output for that, so the universal output. And that output is connected with a live bit that forces the first stage to stop if the second stage is switched off. So normally you would always have this output, the universal output, and if that output goes dead, that means somebody switched off the second stage, and then the first stage will switch off immediately as well. If you have external connections, you can see, as you saw already here, each stage has its own power supply. So the reason for this is we cannot connect 2 pumps to one arrow digital. So each pump has to be connected to its own power supply. Connection of external signals, important to remember, is done only to stage 1, not to stage 2. I see there is a question here. The 2 PR recirculation standard or option, and the connection hoses. So first of all, connection hoses AA and BB, yes, they are within scope of Herco. So when we deliver the unit, it will be delivered with the connections. When we retrofit the unit, we deliver only the second stage, and that stage comes with the connections as well. The PR recirculation of the first unit is, I think, a standard because it's already included. No, wait, the second unit is a standard, that I know, because we used to have the second unit as optional. So first unit is optional, second unit is standard. Reason, you really need the quality after the second unit, right? So, and because this is a relatively, well, not critical application, but an application where the client probably really wants to have less than 5 microsiemens all the time, we have decided to include the second PR as a standard already. We can exactly. So my colleagues are going to check also, but we'll include this. Do you want to check? Let's go back. It seems it doesn't let me go back. No. Let's take this one. I think it's standard.
It's standard here.
It's standard here. We go to the next one.
And this also looks like standard. You know, the options always look like this.
Exactly. So they are not a straight line, but an interrupted line.
This would be an option, and straight lines are not optional. So it looks like it's not an option.
It's included. It's included.
Yes.
Okay, let's go back. Oh, sorry. No, I was too quick. Okay, so remember when we deliver it, it comes with all the connections and all that. So it's complete. When you connect the external signals, as I said, for example, float switch that says the permeate tank is full, you only connect to stage 1 because stage 1 is the leader and gives the signals to stage 2. And when the permeate tank is empty, for example, stage 1 is requested, and stage 1 requests stage 2. We try to design the control for maximum security of supply. So that means you will have an easy job to set it up. You won't get fault messages too early, and it will be smooth to get the 2 stages running together. What other modifications have we done? You have seen the labeling. So we have stage 1 and stage 2. Both of the stages are labeled in German and English. That's because we use the first stage also as the fast track units, so they are pre-produced anyway in a lot of cases. And these are always labeled in German and English, so they can be shipped to all the countries. And you have seen that we have a lot of, let's say, different flows that are returned in one hose. So we have quite a few check valves in there. Permeate recirculation, another permeate recirculation, concentrate recirculation. So it can get a bit confusing. Normally, we do not label the check valves of the units, but in this case, we do label them for troubleshooting so that you can identify exactly which check valves goes with which water stream. What else? The pumps. So you can see here a pump that looks slightly different. For stage 1, we have for the smaller sizes the vane pumps, and for the larger sizes, we have the typical centrifugal pumps, Grundfos pumps you see here. But we use now CREC pumps. That's a new type instead of CRE pumps. That gives us the option to use fewer pump types, so to reduce the variability a bit. It's also good for the clients to have less spare parts, let's say. And what you need to consider with this pump, that the pump is set by a percentage output, not cubic meters per hour. So that is slightly different than what you're used to. We will change these pumps for the UOD series 600 to 2000 in the next 2 months. So from July on, you will get the UOD series 600 to 2000 equipped with these pumps in general. But we'll send out a technical information about that in the next week, most probably. So it's a slightly different adjustment of the pump, but just as easy. And finally, okay, I wrote here optional. Actually, I was wrong. So we have the permeate valves. We have the permeate recirculation that used to be optional, and that is a standard now. And I'm showing you also here the parameterization from the factory of the warning and fault or error messages. Obviously, that's for higher conductivity in stage 1 than in stage 2. Okay, and here finally a comparison of the footprint and unit sizes. You see here the old series, that's the table on the right-hand side. And we had quite a few, well, a few more units, not so many. And we also had larger unit sizes, but as I told you before, those were always customized plans. So we decided to take them out of the catalog. If you need a larger unit, we will design a plan particularly for you and offer you that unit size. Now we switched from the what used to be 300 is now a bit smaller because we've seen a lot of demand for the smaller units as well. So we have a 200p, a 400p. That's not FU or not variable frequency drive because the smaller units are equipped with vane pumps. And then we have the larger sizes, the 750, 1250, and 1700. Those are equipped with a variable frequency drive. We have different sizes now than we used to because we have taken the stages, first and second stage, and we have tried to use exactly the stages we have in the UOD series. So if you have old UOD units, those can be retrofitted. And I'll show you in the next chapter which unit corresponds to which permeate staged unit. You can see for the small units, 200 and 400, that the footprint is a lot smaller than before. This is because we use these standard very small units now. So we have about half the footprint than before. Plus, it's a bit flexible for the installation. So actually, if you want to put one unit in one corner and the other one 3 meters away in another corner, that is possible. So if you are very, very tight with the space, this is a good option. We'll go directly to the installation actually. And we'll go into the retrofitting part because that's an important part. And that's a part where you need to think about a bit to get it right. Okay, so we have, when we want to retrofit or when we want to install these two stages together, basically two connections. One is the hydraulic connection, and one is the electrical connection. If we look at the hydraulic connection, we have these two hoses that we mentioned before. So the permeate from stage 1 to stage 2, that's the AA connection. So this is labeled on the unit, on both units with an A, so it should be easy to find and to connect. And you can see here the permeate connection, first stage to second stage. That is this unit here on the left-hand side. And you can see it's a connection that is directly behind the RO digital controller on the left-hand side. We made it a bit larger. When you stand in front of the unit, it's really easy to find because of the labeling. So it's not hard to connect them. For the these are the larger units. Here you also have a different diameter for the A connection and the B connection. So it's definitely not possible to mix them up. For the smaller units, you have the same diameter for A and B connection, but because of the labeling, it should be also 100% clear where you connect which hose. The BB connection, you see that on the unit in the drawing on the right-hand side. That's also pretty clear where you can find it. And with the labeling, you just take off one part of the, unscrew one part of the piping, connect the hose, and that's it. The hose will be supplied loosely, so we don't connect the units for the transport. Doesn't make sense. It will be harder to transport them. And you connect them directly on site, but it's just screwing, unscrewing, so it's a pretty easy thing. For the units that are retrofitted and where you have already a UOD, you also don't need to change anything. There are some connections that are usually used for cleaning, where you can unscrew some part of the pipework. And these are the connections that we're going to use to include the hoses that take back the water from the second stage. So you never need to manipulate anything about the pipework. It's always just a normal connection. Okay, now the electrical or the mains connection. The hydraulic connection is pretty easy, really. The electrical one is a little bit more complicated, but not too bad. So we have a separate power supply for each stage. That's clear, easy to connect. We have a signal cable to communicate between the stages. And the signal cable will come connected to stage 2 already. So you only have to connect to stage 1. Now, the on-site connection to stage 1 is done via a small control box. So for the sizes 200 or 400, you see this box in the picture. This is a box we usually use, I think, for Profinet. And you connect the cable to that box. When you order the unit, stage 1 already comes equipped with a box, so that's easy. You just need to do the connection. When you retrofit it, we will deliver you all the accessories that are required. So you get the box and all that is inside. But you need to fix the box to stage 1 on site. That's the only difference. For the larger units, that's from 700 size 750 on, we have enough space in the control board, in the switchboard, in the panel to include something that you see here in the picture also. And we connect directly to the control cabinet. So signal cable comes connected to stage 2, has to be connected to stage 1. It is described in detail how to do that. If it's retrofitted, you have to take care of it, how you do the connections. As I said, connection must be made on site. It makes sense because we want to have the flexibility on site to put the units where we want to. It wouldn't make sense to bring them in connected already. Important for retrofitting. Now we want to look at how we make, we take a UOD unit and we make that into a permeate staged unit. We need to think about how can we combine the systems. And that's why I wanted to show you here which stages go together. So if you just order a new unit, UODP, no problem. You get both stages. If you have existing UOD, you can see here the units that can be connected. So a suitable stage 1 is a UOD 300 for the UOD 200P. So if you have a UOD 300 or a UOD 500, 900, 1500, and 2000, those can be upgraded to a 2-stage system, and you just need to get the second stage. So the second stage is not included in our catalog with a separate item number and a separate price, but we can do a quotation. We haven't included it in the catalog for a reason. Usually if you have an upgrade, it's always a customized plant. So we need to check the unit that is installed. What accessories do you have there? Do you have maybe HR membranes, high rejection membranes, which means you have less permeate production than a normal unit? We need to check if you have variable frequency drive on that existing unit, which would also, with a variable frequency drive, it gives you more flow rate than without one. Okay, so this is something that needs to be checked, and that's why we prefer to have this as an inquiry to the sales team. We double check if everything's fine, and then you can get a second stage and simply upgrade your existing UOD unit. When you get the second stage, you will get all the accessories. So you'll get the hoses for connection, you will get the cable, signal cable, and you will get all the accessories for this control box or for the installation in the control cabinet. You just need to connect that to the first stage on site. Okay. The first stage will need to get a new parameterization, so we'll need to update the software as well. Okay, so to recap, if we look at this in total, we try to make a new concept for the permeate staged units. You have the stages designed as separate entities, so you're very flexible. Even if you have little space, you can somehow squeeze them into a corner. You have less footprint. You can retrofit UOD units. And you have an RO digital controller where you can really log all the data, connect to a central control system, maybe for the second stage, maybe for both, whichever you want. And you have energy saving with the variable frequency drive pumps as well. For the larger units from size 1700 on, as you know, you can get them as before as a customized unit. They will usually come with a PLC, but there we are open to your necessities. So those can be adapted whichever way you want. So I hope this was informative. I know there are a lot of details here about the connections, but when you have seen that in reality, it's really not so difficult to do. It's pretty easy. You will get a handout with all this information. When you order the unit, we also describe this really clearly in the operation manual, how to connect the stages, how to start them up, and all that. And if you have any projects where you say, okay, a retrofit would be a great idea, then we're very happy if you contact us, if you contact the sales team to get a quotation.